Welcome to OLM Feature Planning and Issue Triage. Today is Thursday, March 4th. On the agenda today, we have some items from Chris. First one is, can someone provide a feature outlook for the next quarter on RFEs and enhancement proposals? And then there's a list of a few features. So Chris, do you want to maybe go ahead and explain what you look for?
Yeah, so I know like over the past quarter was kind of like a really kind of a maintenance release for OLM and OPM to really try to get some stability and things like that. And so I was wondering if we had a little more clarity on some of the other features that have been discussed over the past 6 months, where what the this quarter and next quarter outlook looks like. I haven't seen a roadmap, so some visibility on what's going on. So these are 5 of the. So I looked through all of the RFE issues in OLM and OPM. I looked at all the PRs that have been done over the past few months. I've looked at the enhancements PRs that have been coming in. So like declarative index, I think that's obviously one that everybody's actively working on. And there's a couple of different enhancement PRs there. The descoping plan, there isn't really an enhancement around that. That's more of a larger thing I know is coming. Basically this cluster scoped operator. CSV Less Bundles, that was something that was going to be tackled pretty heavy, like, I don't know, probably 9 months ago. And that's kind of dwindled off, and I'm wondering where that's at. Another one that I couldn't find an RFE or an EP for was the conditional dependencies, which I know was originally slated for, I think, 4.8, 4.7 or 4.8 of OpenShift anyway in that time frame. So that's basically where you have logical dependencies in the dependencies YAML, so you can group things together. And then I've seen another PR by Ben for the substitutes for, to manipulate the graph that way, like for hot fixes and stuff like that. So those are the ones that I was interested in. And then as a subsequent one, which related to this, as I'm going through all of the EPs, the enhancement proposals, I'm noticing that a lot of the status hasn't been updated when they have been implemented. So it'd be kind of nice if someone went through and kind of updated the status so we could get the clean status of what's actually been done versus what's still sitting out there.
Yeah, fair feedback. I think we need to, in general, do a better job of publicizing our roadmap for one upstream, as well as provide a better feedback mechanism for where things are that have been merged as enhancements. So the reason for this is that our Jira is not public yet. That's right. Just it. I would really love to just be able to point you to our Jira, and then you could basically see everything. But let me share.
I have to ask you this question, so if you could go ahead and show us what's behind the curtain.
Sure. Let me see, to give you just a little bit of a quick outlook. It's always hard to judge which window I'm going to share, but so you should see a Jira portfolio plan called Operator Framework. Okay, so essentially, that's the 4.8 plan. That's what the team is working on right now. So there are a couple of internal things here, but in particular, to address your needs, we are working on declarative index config. So the enhancement for that is still open because there were a couple of minor things that needed to still be discussed. But overall, we felt pretty confident about the spec, and implementation has begun in parallel and will adjust to any changes that might happen there. There's essentially nothing else from your list in here, but I know that the substitutes for hotfix has been worked on, and I think is code complete. I'm not sure if it's already merged. Someone from the team would need to give an update on that. Since this is more like a pipeline thing, and it's kind of behind that, what we call FreshMaker support, it's not something we have made huge strides about externally. but it is something that would essentially also allow your pipeline to do this. And that's subsumed in the FreshMaker support, which is really our ability to have stuff be rebuilt automatically, and then also replaced in place, so to say, in a catalog, right? So we have made the design around using some of these semantic versioning rules and bend them just a little bit so that we can have ordering in place that would allow us to have something similar that RPMs do today with epochs, right? So we have build IDs, and those build IDs reflect updated versions, updated builds that can be ordered. Per Semver spec, those would never be ordered, but we do have you know, an interpretation of that gives it meaning, so that you can have an operator say 150, and let's say that thing has a CVE, right, in the base image, and we automatically use our pipeline to spin the base image to a new version, and that would rebuild your operator. You would get something like 150 -1 or something, and that would be seen as an update by OLM, whereas per Semver rules it would not be an update, sort of. So that's kind of what behind that, and that's what substitutes for was basically required for.
So is that kind of does that supplant what Ben's enhancement was? What was that? This, yeah, substitutes for us, what you just said. All right. So yeah, so all right, so I got to go read about FreshMaker then. I'm not exactly sure.
This is an internal tool in Red Hat. It's probably not something you're going to see a lot of information about, but it's kind of one component in our pipeline that would allow us to automatically update operator releases without too much involvement of the teams behind it that essentially have that operator under their control. But it would be a service of a pipeline that just respins your operator. What it actually does on a broader use case for upstream users as well is allow you to change operators without necessarily triggering a completely new release, right? So if you were just to rebuild the image, but everything in the metadata, in the operator itself, in the code is exactly the same, there's no point in going through the whole pipeline again, right? So what we do is we basically rebuild the operator just with the image, the base image that has the CVE fixed, and that's something we can then update in a catalog so that it's in place of the older version that had a CVE, right?
So how are you dealing with the version collision then? Are you going to annotate like a build number on the end of the Semver then, like a plus something?
Yeah, exactly. Yeah.
So the customer at least knows it's changed, and how do you know it's still? So you're just going to replace then, so the previous one just would disappear?
It would disappear from a catalog in terms of being available to install from it for new users, but for existing users, it would be an update. So that's something we do at the catalog level, and the catalog level would essentially understand how to treat these new builds, essentially, but they are really just that, new builds of the same component, right?
So just to clarify, so these will be, so if you have two builds for the same version, they will both show up in the catalog, but one of them will just not be installable, or they will only be the latest one in the catalog?
That's a good question. I think they will both be referenced in the catalog. I mean, the operators themselves aren't really in the catalog anyway. That's just references to them, right? But from an update graph perspective, I think they would be there, and they would have the substitute for logic that essentially makes OLM behave correctly in terms of new installs, to always prefer the newest thing and not even show the oldest thing. And it would essentially also trigger updates for existing users to basically bump their installed operator to one that doesn't have a CVE.
So is there a way that we can see what this is? This sounds really interesting to me, because we're actually starting to work on some service offerings, some products as a service offerings, and we're going to be, you know, drinking our own wine, eating our own dog food. We're going to actually have our own GitOps processes pushing out operators, and so we're going to want to do hot fixes and things. And this is really, you know, this is interesting because otherwise you have to patch the CSV, which is really ugly. right? We'd rather have something like this.
Yeah, true.
Yeah,
Go ahead, Nick.
I mean, hopefully declarative index will let you do something similar. If not the same thing. I'm not sure the part of the graph building has been worked out yet for declarative index, so that you don't have to like replace content in a CSV. But I do think that's something that should be added there to make it like the de facto thing that everybody goes to, rather than like substitutes for or something like that.
Yeah. So substitutes for is really something for our pipelines, because they can't just move the declarative index from one day to another, right? So they need some time to adjust, and hence that's kind of a stopgap solution to something that the declarative index would just naturally enable, because it has a more direct way to manipulate the catalog. Essentially, you can manipulate the catalog in any way you want, and it's a JSON file in the end. So you can also track it. You can create PRs against it, version it, and we also have functionality in OPM to automate most of the JSON mutation through first-class commands. But effectively, Nick is totally right. This is a stopgap, and the declarative index feature is really what you would be looking for to have much better and much more sane control over what's in the catalog and how do I do things like replacing bundles under certain version tags.
Yeah, I guess I'm
Yeah.
really interested to make sure that, if you're gonna replace, a version, right, like that, if you're just gonna automatically just if you're gonna use like the plus on the end of December, someone's gonna have to be aware of that plus syntax. So either you're gonna have to have something like the replaces logic in there to make that work, to be able to inject it in the middle.
Don't use the plus syntax for anything new. That was specifically added to support existing catalogs that we have, where there was an assumption that that's how semver ordering was happening by an internal customer, and it wasn't, and it was not an option for us to republish their content. So it was a feature that was added to support pre-published content.
Oh, sorry, can you repeat that? So you're saying you do honor, if you have two XYZs with different pluses, you will treat those as separate versions?
Yes, but it's more of like it is very special case that shouldn't be depended on.
Okay. All right. So I still think I need some kind of document that describes what you guys are coming up with, and if there's anything we can use there. So I guess, is the FreshMaker support superseding the I already forgot what that was called, the substitutes for, or is substitutes for still going to be something real that you want to iterate on?
Substitutes for is part of FreshMaker support.
Okay. So
And
we
it
could
is
look at
superseded
substitutes
by the declarative index, actually. So it's really just an in-between step to give our own internal pipelines some time to adjust, because the declarative index is obviously a central change in philosophy of how we treat and build catalogs. So if you have built your pipeline around the idea that you have an image and that you are incrementally adding to this image with OPM index add commands, that idea is going to be deprecated with their declarative index, right? You're going to have a JSON file, and that's the source for your catalog. And you're going to repeatedly build the catalog from that JSON file.
Yep.
And you are essentially able then to mutate that JSON file in any way, shape, or form you want. So all these acrobatics with substitutes for and what enables FreshMaker on our side is essentially not needed anymore. So it's a much better control mechanism.
I read through that real deeply, and I've been actually adding a bunch of questions to it, and I know you've responded to them, so that's great. So for this, so if I have a hotfix, for example, and I need to patch 1.1 and 1.1.0 and 1.1.1 already came out, but I want to patch 1.1.0, I should be able to replace 1.1.0 with 1.1.0 plus some date or some patch ID, and it would still upgrade. Would OLM recognize that that's a new version, or would it leave it alone and think it's still 1.1.0?
It only does that in replaces mode, and it's specifically for choosing the channel heads is where that comes into play for the additive imperative index add commands that we have today.
Well, unfortunately, 1.1.0 is already replaced by 1.1.1, right? And so in my world anyway, and maybe someone has pinned it to 1.1.0 for whatever reason. They don't want to move to the 1.1.1 yet, so they want to, even though it's been replaced, they're still running on that. So there's no way to upgrade that to the patched version. I guess I'm just trying to get the subtlety of how that works.
So if I understand correctly, the question is how would build ID based replacements work
Right.
with declarative index?
Right.
Right. So do we have an answer for that already, Anik or Nick, or do we need to go back and figure that out?
I don't think Anik's here. I'm gonna have to look at his enhancement to see what he added there. I don't know if it is currently still using replaces or if we've moved on to something more advanced where you can like construct what the upgrade graph looks like based on the how the resolver interprets properties. So that's something that I'm going to have to still answer. I'm not sure that this actually addresses that yet.
Okay.
One way that this was at least partially solved, and this isn't a great solution, but I thought that we had started advising folks to use, like when they initially release 1.1.0, to actually release 1.1.0-0, which is technically a pre-release. And then if you ever need to patch 1.1.0, it would just be -1, -2, -3, or a date string or something that was monotonically increasing. I don't know if that's an option, but I think that's probably one way to do it.
I mean, what we can do, right, is we can basically use all those graph control mechanisms that we have. I'm not sure, can you see the GitHub markdown that I'm sharing? Did it change the tab?
Yeah.
Yeah.
Okay.
Yep.
Okay. So you see these properties here. So that's basically graph control, right? For a bundle. So if you release something and you append a build ID or a pre-release version, I guess we could use these controls to kind of insert it in place so that it is an update for the previous build that has a CVE, but it's not, but it's still superseded by the next XYZ version actually. So if you wanted to kind of rebuild an old patch release, right, because there's a super important critical CVE in there, I guess you could have control over that with skip branch and skips, because you can just put that in the catalog in here and can control that however you want. But I'm not sure if that gives enough first class control. And if you have thought about kind of spinning a already released version this way.
Well, it looks like the properties here do allow you to overwrite whatever is coming from the bundle. So what I imagine you do is in your GitOps, you would change the replaces property here to whatever you want when you insert something into the graph. And then you just need to make sure that you construct the graph properly from here. So this probably gives you, this looks like it gives you way more control than what you would have with like some imperative commands to something that's existing.
Yeah, let me noodle on that. This is so yeah, essentially you're giving me all the rope to hang myself with. So I could totally destroy the graph. Is OPM, so with the new declarative index, is OPM going to do any validation to make sure that the graph got built right anymore? Or is OLM gonna have to discover that when it starts actually interrogating it?
What does built right mean?
Well, so today, because OPM deals with edges, right? So when you're adding things to the graph, it can catch some things like if you've made a mistake. Or at least you can query to find out its state through the list bundles to see if you made a mistake, right? I'm just wondering if there's going to be any tooling that'll help you understand what you've done.
There is a validation command. We have tooling for showing you what the graph looks like as in like dot format and stuff like that after it's created. I don't expect it to be any less, this validation for the declarative index to be any less strict than what we already have. But at the end of the day, you're responsible for like making the graph that you want. So if you make something completely wacky, that doesn't make sense semantically. Like version 2 replaces version 27. We wouldn't be able to understand semantic things like that.
No, I understand that. I'm just trying to figure out what tools do I have to write to make sure that we have followed our taxonomies correctly. And if there's going to be any help there.
There's a validate command. Like since this is a JSON file now, it's way easier to grok than a SQLite database.
Right.
So you should be able to like, we're going to provide a schema of some sort for this. So you should be able to use like external validation tooling to write what you need, like you were saying too. It's like part of why we wanted to do it this way.
Right.
Do we see value at all in having some basic interrogation functionality in OPM to the extent that you can ask it, for instance, things like, give me all the bundles that replace version 27, right? Or give me all bundles that are superseding version 27. So kind of a programmatic way to read the graph and emulate what would happen in the cluster as OLM would step through the graph. You know, a picture can help, and a human, right? But if you wanted to do validation in the pipeline, you know, looking at the dot file doesn't really help, right? So if I were to say I'm gonna always replace the newest version, and then I do the OPM index in a certain way, or I actually manipulate the JSON with some clever jQuery, would there be value in having another part of OPM saying, give me all the versions that follow the previous version, and that would be a check where you look for your version that you just added, right? So similar to what, well, not similar, but let's say you could ask the catalog, which versions follow etcd 061? Would that be valuable at all? Because these are some basic interrogation and validation techniques you could use, right?
Yeah, I think so, because then you can do interesting dry run kinds of things to see what's going to happen when I build this catalog and replace a previous catalog. Then I can see what is going to be the effect on the customer. Like, did I do this right? Right. So there's lots of checks and balances that could be developed there. Right now, the whole thing's kind of a black box because it's all locked into the SAT solver, which doesn't give us a lot of visibility what's going on. So we have to use Ben. What is it? Yeah. Ben Luddy's Depster, to try to kind of figure it out to some degree, and it's not ideal in some when you have multi-catalogs and stuff, makes it a little tricky.
Yeah.
Yeah,
I could
well,
imagine
that's kind of where it lives, though, right? Like, so we're the thing that interprets the graph is the thing that understands it, and ultimately OPM doesn't interpret the graph. So when that becomes mainstream, I would imagine anything like that would live there. Or additionally, instead of adding new commands to OPM, I would prefer we tried to implement these things as like scripts first with like JQ and other on top of the declarative config.
Yeah, the trick is you don't know if the rules that you're writing in your scripts match the actual stat solver.
Mm-hmm. Yeah. So
you
it
might
could
be
be
writing a lie.
so I guess there's a common problem space here, right? We need some sort of stat solver dry run capability that can be
Exactly.
exposed
Yes.
to command line interfaces like this, because we need this as well for other stuff inside OLM 2, where I need to be able to tell a user, if you're going to be installing this package right now with the contents in the catalog that I can see now, it's going to resolve 3 additional dependencies and it'll look like this. So I think we have already planned for something like that with the new API structure that we have, but eventually this seems to be a recurring ask. Like, tell me what would happen if I install this. Tell me what version would follow the latest version that is in the catalog right now, or what were the previous versions before that. So interrogating the catalog like this could potentially drive a lot of value in validation steps in pipelines, as well as just individually run commands by catalog maintainers that are publishing. Because I feel like Chris has a point. We only really see what happens when stuff operates on cluster, right? And it should be possible to simulate that, given we have the same content available outside of a cluster.
Exactly. Yep. That's exactly what I'm after. So just I have to run, but I know there's Jeff, James, and John from my team are here, and they can. I guess if you could go through the other things they had in that list and kind of give us an idea of where that lies, like maybe in the next couple of quarters, if they're even in plan, that'd be great. I just wanted one other just tidbit. So we've been working with some really big banks lately. And we've gotten some pretty candid opinions on operators in general from them. And so they really like predictability. they like to take things apart and apply the actual manifest for the deployments and all that stuff directly. And so operators scare them because they are somewhat non-deterministic from that perspective. You can't see what's going to get resolved. And so I think a tool like this would be very helpful, for them to see what's going to happen when I do this, rather than having to test it and then reapply my subscriptions in the catalog and hopefully it runs the same way.
Yeah, just to make sure that we have the scope right, Russ. So we would only simulate catalog and graph behavior, right? We would not.
True. It wouldn't go that deep. I understand.
What would an operator do if I press this button? That's kind of strange.
I know that's another problem we have to deal with too. How do you do it? The explosion of operators begetting operators begetting operators.
Yeah, I do see the need for graph predictability sort of and introspection after the fact. And I also do see the need for dry run of dependency resolution. Like Nick said, all of that is in the stat solver. So I'm not sure like how easy we can make it available to OPM, but I do see the need for that. I do understand that.
All right, cool. All right, I'll let you guys keep going. I guess James and John and Jeff, if you could kind of maybe dive into those other items. If you have other items you want to have Daniel talk about, that'd be great. I'll watch the recording when I get back. All right, thank you.
Sure. The other things on the list we can go through and take a look at. So the descoping plan is something that's actively being worked on Nick, I don't know if we have, I know we have this in a markdown somewhere, but I don't know if we have it published to community users. I don't know how we want to do that, but it's being worked on, and we kind of think that realistically all this work is going to coincide with the new APIs as well. And there's going to be a transition path that we are currently figuring out too. So this is being worked on. It's not something for the next quarter. It's more something towards the end of this year. Because obviously it requires duplication notices and a really rock solid bulletproof migration approach. We are really spending a lot of time and effort on this to get this worked out. Yeah, we could certainly do a bit of a better job to publicize that work and thinking. I think we are like in the 6th iteration of that, but effectively the work around descoping and moving to cluster scoped operators is going to coincide with the work to have an operator API and an understanding of what a bundle is, what an instance of a bundle looks like on a cluster. And that's towards the end of this year. That needs way more work. CSV Less Bundles, on the other hand, is something that we have already looked at, as Chris said earlier. And right now it's slated for the next version of OpenShift. Well, the next version after the version we are currently working on. So that would be 4.9. And then in accordance to that, OLM would get those features. And the idea is obviously to have bundles that to a large extent consist of normal Kubernetes manifests in their plain form and some additional metadata that OLM understands. And that should help with creating bundles in general. And also ship bundles that contain other things that we don't manage today. So one discussion that always comes up, for instance, is in particular pod security policies or security context constraints on OpenShift. In particular, because operators deploy workloads that are somewhat close to the infrastructure or to the hardware, and they need a higher privilege pod security policy or SCC on OpenShift, but they don't need the privileged one, right? So they need something finer grained. Right now, the only option for those operators is to actually have RBAC on this API and create it themselves, which is potentially something that could be considered dangerous, because a very open PSP could, or changing existing PSPs and SCCs would potentially bring clusters in a state where they are not supported anymore or hard to update. So it would be easier for OLM to just allow operators to ship with an SCC that they need for their operands or the operator itself. And then this can be inspected in the pipeline by just extracting the bundle content. And that would allow us to reduce the RBAC or not ask operators to have RBAC on SCCs and PSPs. But in general, that's a 4.9 thing. So that's going to be something we are going to work on after the next release. Conditional dependencies, yeah. Any question to that?
Yeah, this is Nick. I did want to bring up something interesting with CSV Less Bundles. And it has to do with the work that we're doing for supporting cluster scope operators and the operator API. You mentioned representing a bundle on the cluster earlier, Daniel. The current designs are around representing a bundle as a set of resources that are applied to a cluster, and another resource that we're dubbing right now an instance. And the instance reconciles this bundle on the cluster and keeps it applied. Nowhere in that does it require that the content include a CSV. So now we manage things in terms of instances and bundles and not in CSVs. And so we were imagining those things would be completely would not have any sort of allow list. They would be just allowing arbitrary resources to be applied. So conceivably, we could change CSV Less Bundles to not require CSVs be generated in the shorter near term and part of migration if that were in place. So that's just an update on that, if that makes sense.
Yeah, that's why I brought it up. Thank you. So that was an important capability, also to treat in general bundle content that maybe does not resemble an operator. So the long-term approach or like aspiration for OLM is to become more aware of applications in general on the cluster, operators being a very special type of application as a service, if you will. But there is a lot of reusable logic in OLM when it comes to dependency resolution, catalog management, RBAC management, and stuff like that, that would easily be applied to Helm charts as well, for instance. And that's why, as part of the new API landscape that we are working on and architecting, there is enough abstraction in there to easily allow other types of bundles to be applied to the cluster and be subject to the same validation, dependency resolution, catalog management logic that we already have in place for operator bundles. So you could, for instance, imagine that we have Helm-based bundles, right, which would contain Helm charts, or we have cloud-native application bundles, which would contain those kind of manifests, right? And OLM has enough of a generic architecture that would allow to basically plug those in and have classes of bundles available that could be understood in a certain way. So operators is still obviously first and foremost the primary concern, but it's not too hard to extend that to Helm bundles, right? And then we would use the same API in the background, and we would maybe have a Helm chart custom resource that would point to a bundle which actually contains that Helm chart, right? So that's why this infrastructure exists, and it would definitely apply to CSV Less Bundles, but also to bundles that have nothing to do with operators at all. So I guess that's something where we want to make OLM fit for the future, where it can manage more things in the application landscape of Kubernetes clusters, and that's why this exists today. For CSV Less Bundles, I think that would be a thing before the new operator API and those bundle concepts come in, and they would essentially replace the need to have a CSV to install an operator, simply.
It's interesting because we can chop off the bundle and instance stuff earlier than the rest of it and get for free the application of, let's say, a new bundle type that doesn't require CSV, doesn't generate a CSV, doesn't have any of the same assumptions. So that like you just, drop your deployment and all of your stuff in it and it gets managed. So depending on how we get that enhancement out there and break it up, we may be able to shift some things around. These are just thoughts. I don't want to. I'm not trying to counter what Daniel's saying about the current set dates. Assume those unless we say anything else.
Yeah, it would probably be interesting to take a look at this, Nick, and figure out if we can make some of that happen as part of 4.9 already, and then just finish it up in 4.10 with the operator API, or if we need to do some different ordering there. But I'm intrigued by the ability to actually pull that off, and it clearly fits the immediate goal that CSV Less Bundles had, which is you don't really need to do a lot to package your operator for OLM. You probably have all the manifests already, right? Because you so far use Helm charts for that. So just give us all your manifests. And by the way, here's a little metadata YAML that will take your display name, your description, your tagline, and your email address, and that makes enough for metadata to display this in the catalog, right? And all of that goes in a bundle, and then OLM knows how to deal with that because it interprets certain things in that bundle in a special way. So Csv Less Bundles, for instance, would require you to, for instance, drop maybe at least one deployment or one daemon set or one stateful set or whatever we want to allow as part of an operator install into a bundle, right? Otherwise, it's not a valid bundle. Like an operator can't just consist of, I don't know, RBAC or just services, right? It needs to have at least one runnable artifact inside. So we treat some of this stuff special. We look at RBAC rules and derive certain things from that. But all the rest would just simply be applied and be subject to a different and simpler life cycle than the concepts that make an operator today, right? Like it's deployment, it's RBAC, it's service account, and it's custom resource definitions. So you would throw all of that in a folder, and that's something you can call a bundle that would go in an OCI image. You can make that part of the catalog, and then that's a CSV less bundle, right? For you, and that makes the whole packaging journey much easier. You don't need to actually create a CSV. Truth to be told, we have made it significantly easier at the SDK level already. So if you use the operator SDK to write your operator, all those metadata and the entire bundle will be automatically generated for you end to end, right? You will never actually have to touch a CSV at all. It's all based on customized overlays and merge.
I just wanted to point out that we did try to implement CSV Less Bundles back in a prior release, a few releases ago, and I think we ran into some UX issues, and I think that's what held it up. I don't know, Nick, if you recall exactly what it was. It basically was very hard for the user to actually use the feature, and it ended up not being pushed out. I don't know if the declarative index stuff, I guess that's on a higher level, that's on the catalog level, not on the bundle level. I'm wondering if any of those issues that we hit when we tried to implement CSV Less Bundles in the past have actually been resolved, or I haven't gone back. This was last year, so I haven't gone back and looked at it, but we should be aware of that.
I don't think they got resolved. I think a big chunk of the issue is the difference between a bundle on disk and a bundle as an image, and choices with how OPM does scaffolding today for bundle file systems locally before you build it into an image. I don't think any of that has been resolved. That said, I don't think it will be an issue should we reevaluate some things in OPM. I think indexes might suffer from a similar issue of the delineation between an on-disk format and an image format. Just something I was hoping to address with some reviews to the PRs that are ongoing, but I didn't want to open this can of worms any further here. I just wanted to get into the fact that we can, there is a feature along with the new APIs we're developing that will make it so that we don't need to sort of define all of this UX around that at the OPM level.
So I have a quick question.
Go ahead.
So if you have, if you're removing the CSV, there, like you say, that there's pieces of metadata and whatnot that are associated with, being displayed in the user interface and whatnot. So, and I get the point. I think you're trying to say that you're going to detangle some of the things like deployments and whatnot that are currently in the CSV and make them into separate kube objects. But then what happens to the metadata that you do need to actually display for like the user interface purposes or ALM examples or other things like that? Are those going to be independent objects as well?
That's a really good question. They're probably going to be independent objects. There's always the option that they live in the bundle metadata itself, like as labels on the image or something. But there are some technical limitations for like why we can't do that today in Cube, or at least in OpenShift. So yeah, it would probably be an additional resource that you drop in or which gets generated for you.
That makes sense.
And I think there were some other issues that we were debating in terms of how can we derive meaning from certain things that are looking like regular Kubernetes objects. For instance, should we interpret the presence of a namespace object or manifest in the bundle as the desire to put that operator into a namespace? Or is it just something that the operator at some point needs at runtime, but doesn't want to lifecycle itself? Things like that. I wasn't aware that we had like issues with like differences between OCI images and stuff on this, but I guess, yeah, that needs to be revisited. But essentially the idea was, yeah, detangle the stuff, have a clear separation of concerns. What is catalog level metadata? What is runtime metadata? What is metadata specific to OLM versus what is just Kubernetes manifest that you could probably kubectl apply just to your cluster and get started with. And then provide an easier way to package that into one thing called a bundle. So, but yeah, from like a timing perspective, that's what we are looking to tackle next after the 4.8 release, which is setting the foundation with the declarative index for the catalog maintainers actually.
Now that I'm thinking about this more, when we talk about like when I was talking about that bundle resource before, and instances being the thing that like applies and rolls out bundles on the cluster, it appears to me that like the data found within the bundle could be hoisted and projected onto bundles and instances to make that available to a user without like having to create something new like a CSV on the cluster. But just some food for thought.
There's one more thing in the list from Chris that we haven't gotten to yet. It's called Conditional Dependencies or Dependency Logical Groups. Can't find the FRE or the enhancement proposal for that. I'm not 100% sure what is referred to by dependency logical groups. I think conditional dependencies is a vague concept that we kind of thought about last year, where you would have a softer dependency, if you kind of know what I mean. So today dependencies are hard, right? If we can't fulfill them on a cluster, your operator is not going to be installed, right? So that's kind of a black and white decision. So what would be useful for some operators is to have a recommended list of dependencies, if you will, right? So for instance, the query operator can definitely talk to the container native storage operator to deploy a bucket with the object bucket claim API, because query needs an object storage. So that is one way the query operator can interact with another operator, but there are also other operators that fulfill the object bucket claim API. And there could also be a configuration where you don't need an object storage at all, because you're providing one with an off cluster object storage, right? So this is kind of the space where dependencies would be soft in the way that an operator surfaces to the user that it can use other operators, and that information could be taken up by a UI that suggests that, hey, if you install the query operator, you can actually think about installing also the OpenShift container storage operator, or let's say the Azure Services Operator, because both have an API that the query operator can use. But you don't have to, right? You can still kind of say, no, thanks, I'm good. I have my object storage already, don't need an operator for that. And then you would just be able to install the query operator anyway without those soft dependencies being fulfilled. I think we've put that on the back burner because we didn't really see that much feedback for that idea so far, unless you have some ideas around that and use cases that you want to share.
I think one of those is we have a architecture that has some of the dependencies work on all architectures, and some only have a subset. So we have to try to use something different. So how do we have an operator that on a different architecture has different sets of dependencies?
Interesting. Okay. I guess one way is to have a I don't know. Do we actually support this multi-arch bundles? I mean, we could, right? We could have bundles that have. No, we definitely do that. So we do have multi-arch support and operators, right? So you can have operator bundles that are manifest lists, and those manifest lists would have manifests for different architectures like S390, right, or x86 or ARM. And the manifest list for ARM could look different than the manifest for x86 or for S390, right? It could have a different CSV inside, which would have different dependencies that are being required. It's not quite the same use case though, right? It's like conditional dependencies are more like, here's something that the operator could use. So you may want to install it. And then we do all the runtime checking against, does the dependency still make sense? Does it need to be updated? For instance, when the operator is updated, or will the operator be able to update when the dependency has no update? This kind of stuff. But you don't have to, right? That was the idea. So it sounds like you actually have to have different dependencies being installed depending on the platform you're running on.
And I think the other thing about it is just the fact that it seemed, I think the current implementation is pretty much all or nothing. It's like if you declare dependency, it's got to be there. And so I think there were just some situations where it's just not needed for whatever reason, or if it's not, if it's not there, it's not catastrophic, and you just need to be able to have a way to be able to get the operator in place. Because right now, you can have, hundreds of different operators that you don't necessarily need, but because of the dependency that you might need it, because eventually you might install a CR down the road, there becomes this problem of, now you've got to install a whole bunch of operators that may not be usable or needed for the vast majority of the time.
Yeah, I can see that. We have been thinking about adding force override control to operators for unrelated reasons, but it would kind of fall in the same category, right? So let's say you don't have certain dependencies available on the platform that you're on. Could there be an force override switch that you just use and then the operator would install anyway? It's not unthinkable, right? I think like what you're asking for is more like the operator might have 10 dependencies, but I know for sure it will only ever need 3. So how can I get down to 3? Is that a fair summary?
Yeah, I think so. I mean, I think they're just, I can't think of the exact examples at the moment, but I know that there were discussions about, the all or nothing problem and trying to figure out how do we solve that as a, because otherwise I think the install of the one operator just going to hang forever and never be able to complete because the other dependencies just aren't there or can't be installed or whatever. So,
right. So how would you, like, if you had a magic wand, right? How would you ideally envision this to work? You have the situation, you have 10 dependencies, but you can only fulfill 3 of them, and that's fine with you because you know you don't need the others. How would you want to be able to deal with that?
Trying to think of, because I know our cloud factor data is probably the one that's probably driving some of this. I'd have to think about the exact examples of what they were saying. I just know that they had a concept in their product where they had specific pieces that were, could they have like a top level operator that would do the master install, and then they may need to have separate operators that only get invoked if the customer decides that they think they need those pieces. And so it's just a matter of right now. I think there's a big problem for them in, you're forcing things to be installed onto the cluster that you don't ever plan to really use, or in some scenarios for a given customer. So I think that's probably the biggest problem.
Are those dependencies? Sorry.
Yeah, I have a hard stop at top of the hour, but you can go ahead.
Oh, I was just going to ask, like, if those dependencies are standalone, like they can be used separately from the core product, or are they dependent? Sorry, do they require the core product to exist in order to be usable?
Unfortunately, I don't have the exact examples. Unfortunately, yeah, we probably should come back with that.
Yeah.
If there's a particular place where we maybe can drive, because you were saying that you were lacking some of feedback about the idea, is just knowing where to have that conversation. Maybe we can provide some concrete examples, and go from there.
I would suggest maybe just opening an issue is a fair way to start. I think this is a good thing to track, and we can discuss more. I do want to kind of call things now because we have a hard stop at 11 here for some folks. So let's continue the conversation. I would say if you open an issue, we can definitely discuss it from there next time. So thanks everyone for attending today, and we'll see you all at the working group meeting next week. Bye.
Bye.